Hello, I am Kiera Bacon
And I'm Sam Pollock.
with the game 2005 Assignment 1, Motion in 1 and 2 Directions. This project is to create a physics simulation of a thermal detonator being thrown by a Wookiee to a stormtrooper. Can you hit the evil Chibi Imperial? To solve this problem, we can categorize it as a parabolic motion across a flat surface. We can simply use the kinematic equation for range, r equals v squared sin 2 theta over g. To find the optimal angle to throw, we simply need to rearrange the equation to solve for theta. Likewise, we can use the same equation with 45 degrees to find the maximum range possible. The only object in the scene which responds to physics is the thermal detonator itself. After it is thrown using the parameters given by the player, the thermal detonator will continue traveling on the x-axis with the same speed indefinitely. However, if gravity is enabled, on the y-axis, the detonator will accelerate downward according to gravity, which defaults to 9.8 pixels per second squared. We created a custom class for the physics simulation variables in order to do all of the range calculations and display the two possible trajectories. This class uses the same formula as from the physics problem in part 1. And whenever the player adjusts any of the sliders, it simply does the same calculation again, as you can see right now at the top of the screen. Adjusting the dependent variable the player has chosen from the radio buttons in IamGUI. As you can see in line 46, the trajectories are drawn as a series of points calculated based on a fixed time step. I will now pass it over to Sam to explain the IamGUI functions.
Thanks, Kiera. Down here in the placing, we've got the IamGUI implementation. It's where we set up the checkboxes for gravity, as well as showing the trajectory and complementary trajectory lines. And here, each of the sliders have a corresponding float in the simulation class. So depending on which variable you have checked as the dependent variable, adjusting any of these sliders will adjust their corresponding values to achieve the accurate variable values. And then Kiera is going to take you for a look at how the labels work at the top of the screen in the in-game UI.
All right. So, because all of the variables we're working with are floats, making the labels look clean was a pretty big challenge. We decided to go with an O-string stream object, and then use the stream manipulator functions, set precision, to set the precision of the float that gets displayed. We separated the x and y components of the detonator's velocity into two labels to show the range and height it reaches. But for the range to show properly, we have to subtract the Wookiee's own position, and for the height to show properly, we have to subtract the height from the Wookiee's position. And I believe that's everything we wanted to tell you now. Thank you.
Okay, thanks for taking a look. One final launch.
I think